Tonight, we settle our attention far beneath the familiar surface of the sea, into a place where daylight has never arrived, and where time seems to move with remarkable patience. It is easy to imagine the deep ocean as empty because our eyes are accustomed to measuring life by light. Yet in the quiet darkness below, countless living creatures continue their gentle routines exactly as they have for millions of years, asking for very little beyond the steady rhythm of water and the gradual arrival of nourishment from above. The deepest regions of the ocean begin well below the reach of sunlight. Long before human beings learned to cross oceans with ships or explore the sky with telescopes, these immense underwater landscapes already stretched across the planet, hidden beneath waves that reflected the changing weather overhead. Empires rose and disappeared. Forests grew and faded. Mountains slowly changed shape beneath rain and ice. Still, the darkness at the bottom of the sea remained almost exactly as it had always been. If someone could descend slowly through the layers of water, there would be no sudden boundary between brightness and night. Instead, the light would quietly diminish. Colors would begin to soften. Reds would disappear first, leaving blues that themselves would gradually fade into gray. Eventually, even blue would surrender, until the surrounding water became an endless shade that the human eye would simply call black. Yet, blackness in the deep ocean is rarely empty. Tiny drifting particles move continuously through the water. Some are grains of mineral dust carried by rivers long ago. Others are fragments of microscopic shells, delicate remains of creatures that spent their brief lives floating near the surface beneath the warmth of the sun. Their long descent through thousands of meters of water has been compared to gentle snowfall, and scientists often refer to this endless rain of organic material as marine snow. Marine snow is not frozen, nor especially bright, but it shares something with winter snowfall on a quiet evening. Both fall without hurry. Both connect distant worlds. Snow links clouds with forests below. Marine snow links the bright surface of the ocean with its deepest valleys, carrying energy downward one tiny fragment at a time. Many animals of the abyss spend their entire lives waiting for this slow rain. There is no impatience in their waiting, because evolution has shaped them for a world where abundance is rare, and speed often wastes precious energy. Every movement has a cost. Every heartbeat represents a careful investment in survival. This quiet economy of motion appears again and again throughout the deep sea. A fish may remain nearly motionless for long stretches of time. A sea cucumber may advance only a few centimeters in an hour. A brittle star may slowly extend one delicate arm after another across soft sediment, searching patiently for edible particles that have drifted down from waters far above. To human observers accustomed to clocks, schedules, and constant movement, such lives may seem uneventful. Yet another way to understand them is as remarkable examples of balance. These creatures have solved the challenge of existing in one of Earth's least generous environments, not by rushing through it, but by adapting themselves to its slow generosity. Far above, waves continue to rise and fall beneath changing weather. Storms travel across oceans. Whales breathe beneath the morning sky. Fishing boats return to harbor. Children build castles on beaches where warm sand meets gentle surf. Most of those moments never directly touch the creatures waiting several kilometers below. The deep ocean exists alongside our familiar world, close in distance, yet astonishingly separate in experience. Pressure increases steadily with depth. Every 10 meters of seawater adds another atmosphere of pressure. At the deepest ocean trenches, this pressure becomes almost unimaginable from a human perspective, exceeding 1,000 times the atmospheric pressure experienced at sea level. Rather than struggling against these conditions, deep-sea organisms have gradually become part of them. Their cells, proteins, and membranes function within immense pressure because evolution has quietly refined countless generations to do exactly that. A pressure that would instantly damage ordinary human equipment simply feels normal to a fish that has never known anything else. Normal is always relative. A creature born beneath 6,000 meters of water does not consider itself remarkable. It simply opens its mouth when food drifts close enough. It conserves energy. It reproduces when conditions allow. It continues the ancient rhythm that sustained its ancestors long before humans wondered what existed beneath the waves. In this way, every living thing becomes a reminder that life is wonderfully flexible. Wherever conditions remain stable for long enough, evolution begins writing solutions with extraordinary patience. Some of the quietest residents of the ocean floor belong to a group known as sea cucumbers. Their appearance has inspired many comparisons, though none entirely captures their gentle simplicity. Soft-bodied and elongated, they rest upon sediments that have accumulated over immense stretches of geological time. The ocean floor beneath them is not smooth. It is composed of tiny fragments from countless origins. Volcanic ash settles there. Mineral particles arrive from distant continents. Skeletons of microscopic plankton gradually accumulate into soft layers. Tiny remains of shells drift downward for centuries before finally coming to rest. As sea cucumbers slowly move across these sediments, they gather mouthfuls of material and separate edible organic particles from the surrounding grains. Their meals consist largely of leftovers from ecosystems far above. Nothing is hurried. Nothing is wasted. Scientists sometimes describe these animals as important recyclers of the deep sea because they continually process sediments, returning nutrients that other organisms can eventually use. Even in darkness, ecosystems remain connected through countless quiet exchanges. The idea of recycling is often associated with modern environmental awareness, but nature has practiced careful reuse for billions of years. Fallen leaves nourish forests. Dead trees shelter insects and fungi. Marine snow feeds creatures beyond the reach of sunlight. Across Earth, endings quietly become beginnings in ways that rarely attract attention. Elsewhere on the seabed, delicate glass sponges rise from the sediment like frozen sculptures. Their skeletons contain intricate structures built from silica, the same material found in ordinary sand. Under magnification, these tiny architectural forms reveal astonishing geometric precision. Glass sponges often grow very slowly. Some species may live for centuries under stable conditions. During that time, ocean currents gently flow through their bodies, carrying microscopic food particles while removing waste. There is little urgency in such an existence. Growth occurs almost too gradually for daily observation, yet over decades subtle changes become unmistakable. Their quiet persistence reminds us that speed is only one measure of success. Many of Earth's longest-lived organisms achieve longevity through stability rather than rapid expansion. The deep ocean encourages this lesson repeatedly. Energy is precious. Movement is deliberate. Patience is rewarded. Not far away, soft corals extend delicate branches into slow-moving currents. Unlike the colorful coral reefs found in warm tropical waters, many deep-sea corals live without assistance from sunlight-dependent algae. Instead, they capture tiny drifting organisms carried toward them by gentle underwater currents. Some deep-water coral colonies have grown continuously for hundreds or even thousands of years. Layer by layer, branch by branch, they slowly construct underwater habitats that shelter fish, crustaceans, worms, and countless other forms of life. To imagine a coral quietly growing for 1,000 years is to stretch the ordinary human sense of time until it becomes almost transparent. Entire civilizations have appeared during such intervals. Languages have changed. Maps have been redrawn. Yet somewhere beneath the ocean, a coral colony has simply continued, adding another small branch. Time behaves differently depending upon where one chooses to observe it. The stars remind us of cosmic time. Mountains reveal geological time. Deep ocean offers biological time measured in extraordinary patience. As researchers continue exploring these hidden environments with remotely operated vehicles and specialized submarines, they frequently encounter species never previously described. The deep sea remains one of the least explored habitats on our planet. Current evidence suggests that many organisms still await discovery, living quiet lives entirely unnoticed by humanity. There is something comforting about that thought. In an age when so much of the world has been carefully mapped and photographed, vast regions of quiet mystery still remain beneath familiar oceans. Discovery continues, not because nature hides itself deliberately, but because the planet is simply larger, deeper, and more intricate than our daily experience often suggests. Some fish living in these depths possess unusually large mouths relative to their bodies. At first glance, this may seem surprising, but the explanation is wonderfully practical. Meals can be unpredictable. When food finally appears, the opportunity may not return for days or even weeks. A mouth capable of swallowing relatively large prey becomes a valuable adaptation in a landscape where every successful meal matters. Even this strategy reflects the calm logic of the deep sea. Nothing is excessive. Everything serves a purpose, shaped gradually over immense spans of time. Meanwhile, tiny amphipods continue exploring the sediment grain by grain. These small crustaceans resemble distant relatives of familiar shrimp, though many deep-sea species have developed unique adaptations to pressure, darkness, and scarce food. They search continuously among the particles settling onto the seafloor, becoming an essential part of the ecosystem's quiet recycling. Every handful of deep-sea sediment contains a hidden community. Microscopic organisms, worms, crustaceans, bacteria, and countless other forms of life occupy spaces far too small for human eyes alone to appreciate. What appears empty from a distance often contains extraordinary complexity upon closer examination. The same truth appears throughout nature. A drop of pond water contains worlds invisible without magnification. A forest floor supports entire civilizations of insects and fungi. A spoonful of ocean sediment may contain histories unfolding at microscopic scales. Perhaps this is one of science's gentlest gifts. It reminds us that wonder rarely depends upon size. Sometimes the smallest communities quietly sustain the largest systems. Far above the abyss, moonlight may shimmer across calm waves. Sailors crossing the ocean might look upward toward familiar constellations, unaware that thousands of meters below, sea cucumbers continue their patient journeys across ancient sediment, while glass sponges filter silent currents and delicate corals extend branches almost imperceptibly through the passing centuries. The same ocean holds both worlds at once. One reflects the stars. The other quietly keeps its own timeless company beneath them. And somewhere between those distant layers of water, countless drifting particles continue their slow descent, connecting surface and seafloor in an endless journey that has continued for millions of years. One quiet fragment after another. Water at great depth is remarkably stable, while the surface of the ocean responds to passing winds, changing seasons, and the warmth of the sun. The abyss experiences a gentler rhythm. Temperatures remain only a few degrees above freezing in many places, and the darkness is so complete that day and night become almost meaningless. If one could quietly remain there for many hours, there would be no sunrise to anticipate and no sunset to observe. Time would instead be measured by slower companions, the drifting of currents, the arrival of marine snow, and the quiet movements of nearby creatures. It is curious that some of the calmest places on Earth exist beneath one of its most dynamic surfaces. A storm powerful enough to send towering waves across an entire ocean may leave little immediate trace several kilometers below. The water at the bottom continues its patient existence, while thunder rolls overhead in a world it has never seen. The ocean is layered in ways that are not immediately visible. Differences in temperature and salinity create boundaries through which water moves only gradually. These invisible layers resemble the pages of an ancient book, each holding its own story while remaining connected to the others. Molecule by molecule, current by current, they exchange heat, dissolved minerals, and tiny forms of life over years, decades, and even centuries. Some deep currents travel astonishing distances. A parcel of cold water formed near the icy edges of Antarctica may begin a slow journey that eventually carries it through the deepest basins of several oceans. Scientists describe this global circulation as part of the ocean's great conveyor, though the word conveyor can sound faster than the reality. In truth, these waters drift with extraordinary patience. A journey may take hundreds or even 1,000 years before the water again approaches the surface. It is a comforting thought that some water now resting quietly in the abyss may have begun its voyage long before the invention of the printing press, before many of the world's oldest universities welcomed their first students, before countless generations looked upward at the same stars that still appear each night. Water remembers its path not through memory in the human sense, but through the steady guidance of physics. Gravity, Earth's rotation, temperature, and salt quietly shape every movement. There is no need for haste. The ocean has always been willing to wait. Among these slow-moving currents drifts another remarkable resident of the deep, the giant isopod. At first glance, the giant isopod may appear unusual, even slightly ancient, with overlapping armored plates and many carefully arranged legs. Yet beneath its distinctive appearance lies a familiar connection. It belongs to a group of crustaceans related, in a distant way, to the small woodlice that quietly wander beneath stones and fallen logs in gardens around the world. Evolution often enjoys repeating successful ideas. A body plan that works well in one environment may, over millions of years, become adapted for another entirely different landscape. The result is not repetition, but variation, each version shaped by local conditions with quiet precision. The giant isopod spends much of its life walking across the seafloor in search of food. Unlike animals that pursue prey over great distances, it often relies on opportunity. A fish that has died near the surface may slowly sink through thousands of meters of water before finally reaching the bottom. By then, many scavengers have already sensed its arrival. Scientists are still investigating exactly how some deep-sea scavengers detect food from such remarkable distances. Chemical signals carried gently by currents appear to play an important role. Molecules released from decaying organic matter spread through the surrounding water, creating invisible trails that patient animals quietly follow. There is no competition in the dramatic sense, often imagined in stories about predators. Instead, there is careful timing. Each creature arrives when it can. Each takes what it needs. Eventually, almost nothing remains except bones, scattered minerals, and nutrients ready to enter another cycle of life. Even a whale, among the largest animals ever to live on Earth, eventually becomes part of this quiet exchange. When a whale dies, its body begins an extraordinary final journey known as a whale fall. Slowly, almost gracefully, the immense body descends through the water column. The descent may take hours, perhaps longer depending on its size and condition. At last, it comes to rest upon the seafloor. For the creatures living nearby, such an event represents an abundance that may appear only rarely. First come larger scavengers. Deep-sea fish, giant isopods, amphipods, and crabs feed upon the soft tissues. Over weeks and months, smaller organisms continue the work. Later still, bacteria and specialized worms begin extracting nutrients even from the bones themselves. Some of these worms belong to a remarkable group known as ostacs, often called bone-eating worms. They have no mouths in the ordinary sense. Instead, they host bacteria that help them obtain nutrients directly from the whale's skeleton. Their feathery structures wave gently in the surrounding water, while hidden root-like tissues extend into the bone. Such adaptations may seem extraordinary, yet they emerge naturally from the quiet logic of evolution. Wherever a reliable source of energy exists, life gradually discovers ways to make gentle use of it. A single whale fall can support entire communities for decades. Imagine a quiet village suddenly appearing in an empty valley, not through construction, but through opportunity. Small creatures arrive first, others follow. New relationships develop. Generations are born and live their entire lives around this unexpected source of nourishment before, gradually, the resources fade. Long after the whale itself has disappeared, subtle traces of its presence may remain within the surrounding ecosystem. Nature has an extraordinary ability to transform endings into beginnings without ceremony. Elsewhere on the seabed, sea stars move with measured confidence across soft sediment. Their tube feet, powered by a remarkable hydraulic system, allow them to grip surfaces and glide almost silently over the ocean floor. Though their movement is slow, it is remarkably effective. Each tube foot operates through changes in water pressure inside the animal's body. Tiny muscles and fluid-filled canals work together with elegant simplicity. There are no hurried gestures. Every movement unfolds with quiet certainty, one small step following another. Many deep-sea sea stars feed upon animals that remain almost entirely still themselves. Mussels, clams, and other invertebrates often rely on protective shells or burrowing behavior rather than speed. Predators and prey alike participate in a world where motion is deliberate rather than frantic. Perhaps the deep ocean teaches that survival does not always belong to the fastest. Sometimes it belongs to those who spend their energy wisely. Far above, schools of fish flash through sunlit waters in coordinated movement. Birds glide just above the waves. Dolphins leap into the air before disappearing once more beneath the sea. The abyss has no such displays. Its beauty is quieter. Its stories unfold over longer periods. Its rhythms are written in patience rather than spectacle. There are places where the seafloor itself rises into underwater mountains known as seamounts. Though hidden beneath hundreds or thousands of meters of water, these mountains influence the movement of currents, much as islands shape the winds above the sea. As currents encounter a seamount, they are gently redirected upward. This upward movement can carry nutrients toward higher layers of the ocean, while bringing drifting food toward animals living upon the rocky slopes. For this reason, seamounts often support surprisingly rich communities. Cold water corals spread across exposed rocks. Sponges filter passing water. Crinoids, sometimes called sea lilies despite being animals rather than plants, extend graceful feather-like arms into the current. Deep-sea fish patrol quietly between these living structures. Seen through the lights of a research submarine, such places can resemble underwater forests, gently swaying in a current too slow to notice from moment to moment. Crinoids possess one of the oldest body plans still found in today's oceans. Their ancestors lived hundreds of millions of years ago, long before dinosaurs appeared on land. Fossils preserved within ancient limestone reveal seas once filled with their delicate forms. To encounter a living crinoid today is to glimpse a design that has endured through extraordinary chapters of Earth's history. Asteroids struck, continents drifted apart, mountain ranges rose, ice ages advanced and retreated. Yet these gentle animals continued filtering food from quiet currents beneath changing oceans. Their persistence is less a story of resisting change than of quietly adapting to it. Adaptation rarely announces itself. It happens generation by generation, almost invisibly, until millions of years later, entirely new possibilities have emerged. Nearby, brittle stars often gather in remarkable numbers. During certain conditions, thousands may cover sections of the seafloor, each extending slender arms into gentle currents to capture drifting particles. From above, their movements resemble fields of underwater grasses stirred by an invisible breeze. No single brittle star controls the pattern. Each simply responds to local conditions. Together, countless independent actions create a larger harmony. Nature often builds complexity through many simple behaviors unfolding side by side. Clouds form from countless droplets. Forests emerge from individual trees. Coral reefs arise from tiny animals working generation after generation. Even the vast ecosystems of the deep sea depend upon innumerable small lives quietly contributing to something far greater than themselves. As remotely operated vehicles continue exploring previously unseen regions, researchers often pause simply to observe. Modern technology allows cameras to remain on the seafloor for extended periods, recording behaviors that earlier generations of scientists could scarcely imagine witnessing. Sometimes, the recordings reveal dramatic discoveries. More often, they reveal something gentler. A fish waiting, a sponge filtering water, a shrimp cleaning its antennae, a sea cucumber continuing its slow journey across ancient sediment. These moments may seem ordinary, yet they remind us that most of life is composed not of extraordinary events, but of quiet continuity. Perhaps this is why the deep ocean feels strangely peaceful to contemplate. Its inhabitants are not concerned with tomorrow's headlines or yesterday's worries. They participate instead in rhythms measured by currents, chemistry, gravity, and the slow passage of geological time. The ocean asks for no applause as it continues these ancient conversations. It simply breathes through its tides, circulates its waters across centuries, and shelters lives that have learned to flourish without sunlight, without haste, and without ever needing to be seen. And somewhere in that immense darkness, where the water remains forever cold, and the currents continue their patient wandering, another gentle snowfall of marine snow is already descending from the distant world above, carrying tomorrow's nourishment one tiny, silent particle at a time. There are places in the deep ocean where the seafloor is not covered by soft sediment alone, but broken into long ridges and scattered cliffs of volcanic rock. These landscapes were not shaped by rivers or rain, for no raindrop has ever fallen there. Instead, they were formed by the quiet restlessness of our planet itself. Far beneath the ocean, the Earth's interior slowly releases heat that has remained since the world's earliest history, along with energy produced by the gentle decay of radioactive elements within its mantle. Although the ground beneath the abyss may appear motionless to us, it is always changing, just very slowly. The immense plates that form Earth's outer shell continue to drift across the planet at roughly the speed that fingernails grow. It is an almost unimaginably patient movement. A human lifetime is too brief to notice it directly. Yet over millions of years, continents travel across oceans, mountain ranges rise, and entire seas gradually appear or disappear. The deep ocean quietly records these slow journeys. At certain places where tectonic plates move apart, new ocean floor is continuously created. Molten rock rises from below, cools beneath the surrounding water, and becomes part of the expanding seabed. The process has been continuing for well over 100 million years, adding fresh layers to a landscape that remains hidden beneath thousands of meters of water. If time could be accelerated until millions of years passed like drifting clouds, the ocean floor would appear almost alive. New crust would slowly emerge. Older crust would drift away. Trenches would receive ancient sections back into Earth's interior. Yet, at the pace we experience our own lives, everything feels wonderfully still. Perhaps stillness is often a matter of perspective. One of the most remarkable discoveries of 20th century science emerged from these underwater volcanic regions. In 1977, researchers exploring the deep waters near the Galapagos Islands encountered something few had expected. Surrounding openings in the seafloor where hot, mineral-rich water emerged, they found entire communities of living organisms flourishing in complete darkness. These places became known as hydrothermal vents. Until that time, many scientists had assumed that nearly all ecosystems ultimately depended upon sunlight. Plants, algae, and microscopic phytoplankton capture solar energy through photosynthesis, forming the foundation of food webs across much of the earth. The hydrothermal vents revealed another possibility. Here, life was built upon chemistry rather than light. The water emerging from some hydrothermal vents has been heated deep within the Earth's crust. As it passes through hot rocks, it dissolves minerals before flowing back into the cold ocean. When the warm, mineral-rich water meets the surrounding seawater, dissolved substances begin to precipitate, gradually building chimney-like structures that may rise several stories above the seafloor. These chimneys do not appear overnight. Layer by layer, minerals settle and harden, constructing intricate towers that resemble ancient castles quietly assembled beneath the sea. Around these structures live remarkable bacteria. Instead of using sunlight, many obtain energy through chemical reactions involving hydrogen sulfide and other compounds released by the vents. This process, known as chemosynthesis, allows them to produce organic matter without any dependence on daylight. It is one of nature's quiet reminders that life often discovers possibilities beyond our first expectations. Wherever energy exists in a form that biology can gently use, evolution begins exploring. The bacteria become the foundation for entire ecosystems. Some grow as soft white mats upon the rocks. Others live inside the bodies of larger animals, forming partnerships that have developed over countless generations. One of the best-known residents of hydrothermal vents is the giant tubeworm. At first glance, it appears almost like a delicate flower rising from the darkness. A long white tube anchors it to the rocky surface, while a deep red plume extends into the surrounding water. Unlike most familiar animals, the giant tubeworm has no mouth, no stomach, and no digestive tract. Instead, it houses billions of chemosynthetic bacteria within a specialized organ. The worm provides the bacteria with chemicals gathered from the surrounding water. In return, the bacteria produce nutrients that sustain their host. Neither partner could thrive in quite the same way without the other. This relationship is known as symbiosis, and it represents one of the most graceful themes repeated throughout nature. Flowers and pollinating insects, corals and microscopic algae, humans and the trillions of microorganisms that quietly inhabit our own digestive systems. Again and again, evolution demonstrates that cooperation can become as powerful as competition. The giant tubeworm is not merely surviving beside its bacterial companions. It is living with them. Nearby, vent crabs wander carefully across warm rocks, while shrimp gather in remarkable numbers around the shimmering water emerging from the chimneys. Certain species possess specialized organs that appear capable of detecting faint warmth, or perhaps subtle differences in light emitted by the vents themselves. Though scientists continue to investigate exactly how these remarkable senses function. Even here, Uncertainty remains an important companion to knowledge. Each expedition answers some questions while gently uncovering new ones. The deep ocean is generous in that way. It rarely offers a final answer. Instead, it quietly invites another careful observation. Hydrothermal vents are temporary features on geological timescales. Some remain active for decades or centuries before changing or becoming dormant. As conditions shift, the communities surrounding them must also change. Certain animals produce larvae that drift through the deep ocean, carried by slow currents until they encounter another suitable vent. Many will never find one. A fortunate few eventually settle upon fresh volcanic rock where warm mineral-rich water continues to emerge. Their journey is largely invisible. Tiny lives drift through immense darkness, guided not by intention, but by currents and probability. It is another reminder that much of nature unfolds without hurry or certainty. Far from the hydrothermal vents, in quieter regions of the abyss, life follows different rhythms. The sediment there may remain undisturbed for long periods, accumulating grain upon grain through thousands of years. Every layer contains tiny records of the past. Microscopic shells settle gently after their owners complete their brief lives near the surface. Volcanic ash from distant eruptions drifts downward through the water. Dust carried into the atmosphere from deserts on distant continents eventually finds its way into the sea before slowly sinking toward the bottom. In this way, the ocean floor becomes a patient archive. Scientists who collect long cylinders of sediment, known as sediment cores, can examine these layers much as historians read chapters in an ancient manuscript. The chemistry preserved within the sediments reveals changing climates. Tiny fossils record shifts in ocean temperatures. Fragments of pollen carried by rivers speak quietly of forests that once covered distant landscapes. Even the smallest particles become storytellers when viewed with careful attention. The deep ocean remembers what the surface sometimes forgets. It preserves traces of changing ice ages, warming periods, volcanic eruptions, and gradual transformations that unfolded over hundreds of thousands of years. Our own lives occupy only a very thin layer within that enormous archive. Yet that does not make them insignificant. A single page still belongs within a long and meaningful book. Elsewhere across the seafloor, delicate sea pens rise from the sediment like feathered quills placed gently into soft earth. Despite their appearance, they are not plants. They are colonies of tiny animals called polyps, each contributing to the life of the larger structure. During quiet periods, they extend into passing currents, capturing microscopic food drifting through the water. If disturbed, some species slowly withdraw into the sediment, disappearing almost completely until calm returns. Their movements are unhurried, almost thoughtful. Nothing about the deep sea encourages wasteful motion. Energy saved today may become essential tomorrow. Nearby, a small fish settles onto the seabed. For several minutes, it barely moves. Only the steady opening and closing of its gills reveals the quiet work of breathing. Its eyes remain alert, though there is little light to gather. Many deep-sea fish possess eyes adapted to detect the faintest glimmers, whether produced by distant bioluminescent organisms or the occasional trace of light filtering down from far above. Others have followed a different evolutionary path. In some species living at extreme depths, vision becomes less useful than other senses. Smell, touch, and the ability to detect tiny vibrations through the surrounding water grow increasingly important. Evolution does not insist upon preserving every feature. It quietly strengthens what is useful and allows other traits to fade when circumstances change. The process carries no judgment, only adaptation. Even this can offer a gentle reflection. Life does not require perfection. It asks only for enough balance to continue. Above the abyss, the moon continues its familiar orbit around Earth. Its gravity gently lifts entire oceans, creating tides that circle the planet with patient regularity. Although the deep seafloor seems far removed from the changing surface, even these distant waters quietly respond to tidal forces. The movements are subtle, often measured in slow currents rather than crashing waves, yet they remind us that every part of the ocean remains connected. Nothing beneath the sea exists entirely alone. The winds influence the waves influence the currents transport nutrients, the nutrients sustain microscopic life. Microscopic life supports larger creatures. Eventually, tiny fragments drift downward as marine snow. The slow rain reaches the seabed, and there, another patient animal begins its quiet meal. The cycle is so vast that no single creature experiences all of it. Each participates in only a small portion. Perhaps that is enough. The ocean has never asked any one inhabitant to understand the whole of its immense design. It simply offers each life a place within the larger rhythm, where countless gentle processes continue side by side, unseen by most of the world, yet faithfully shaping the living planet one quiet moment after another. In many parts of the deep ocean, the water itself becomes a kind of landscape. Although it appears clear to human eyes, it is never entirely empty. Tiny differences in temperature, salt content, and density create slow-moving layers that slide gently past one another, almost like invisible rivers flowing through the sea. A creature that spends its entire life in these depths experiences these currents as we might experience the changing winds across an open plain. Some of these underwater currents are so steady that they have continued along similar paths for centuries. They carry dissolved oxygen from distant regions, transport nutrients between ocean basins, and quietly connect places separated by thousands of kilometers. No road marks their course, and no sign announces their direction. Yet countless animals have adapted to their presence, orienting themselves to these slow movements as naturally as birds respond to the changing air. If we imagine drifting with one of these currents, there would be little sense of speed. Hours might pass without any obvious change, the darkness would remain complete. The water would stay cold and still. Only the gradual appearance of unfamiliar rocks or distant animals would reveal that the journey had continued. Perhaps some of the greatest journeys in nature are the ones that unfold so slowly they almost escape our notice. Among the travelers of the deep are gelatinous animals whose bodies seem almost too delicate for such an immense world. Deep-sea jellyfish drift with remarkable grace, allowing the surrounding water to carry them where it will. Their bodies contain very little solid material. Much of what they are is simply water arranged into living form. This elegant simplicity is one reason jellyfish have persisted for hundreds of millions of years. Long before flowering plants covered the continents, before birds filled the skies with song, and before mammals became abundant, jellyfish already drifted through ancient seas. The oceans surrounding those distant worlds looked different from today's, and many familiar coastlines had yet to exist. Yet these soft-bodied creatures continued their quiet lives, opening and closing their translucent bells with gentle rhythm. Sometimes the oldest designs remain because they continue to work beautifully. Many deep-sea jellyfish produce their own light through bioluminescence. In complete darkness, a faint blue or green glow can travel across their bodies like a slow breath. Scientists understand much about the chemistry behind this light, though many details remain under investigation, especially among newly discovered species. Unlike the bright lamps that illuminate our cities, bioluminescence is remarkably gentle. The light is often soft enough that it barely reaches beyond the animal producing it. A brief pulse may communicate with another member of the same species, confuse a predator, or attract curious prey. In other cases, the exact purpose remains uncertain. Not every question in biology has already been answered. The deep sea reminds us of this with quiet consistency. There is comfort in recognizing that the world still contains mysteries, not because knowledge has failed, but because nature is wonderfully abundant. Imagine watching one of these jellyfish drift through the darkness. Its delicate body expands, then slowly contracts. A gentle pulse carries it forward. Tiny points of living light shimmer along transparent tissues before gradually fading once more into black water. The movement resembles breathing. Not hurried breathing after exertion, but the slow, peaceful rhythm of someone deeply asleep. Far below the waves, life itself seems to inhale and exhale with similar patience. Elsewhere, another remarkable group of animals moves through the darkness with equal calm. Comb jellies, despite their name, are not true jellyfish. They belong to a completely different branch of the animal kingdom. Their bodies are lined with rows of tiny hair-like structures called cilia, which beat together in perfect coordination. Unlike the muscular contractions of jellyfish, comb jellies move by the synchronized motion of countless microscopic cilia. The effect is almost silent. As light from a research submarine passes across them, these rows sometimes scatter the illumination into shimmering rainbow colors. The colors are not produced by pigments, but by the way light interacts with the moving cilia. For a brief moment, an otherwise invisible animal becomes a floating prism suspended in black water. Then it drifts onward. Scientists continue to study the evolutionary history of comb jellies because they occupy an important place in understanding the early development of animal life. Their simple bodies and distinctive biology provide clues about events that occurred hundreds of millions of years ago, when multicellular organisms were first diversifying in Earth's ancient oceans. It is remarkable that answers about our distant biological past may still be drifting quietly through today's deepest seas. The ocean often preserves echoes of history in living form. Not far away, delicate siphonophores extend through the darkness like impossibly long living threads. Although they may appear to be single animals, siphonophores are actually colonies composed of many specialized individuals called zooids. Each zooid performs a particular role. Some capture food, some reproduce, some provide movement, others offer protection. Together they function as a single integrated organism. It is a beautiful example of cooperation expressed through biology itself. One part cannot easily live without the others. The colony succeeds because each member quietly fulfills its own purpose. Among the longest known siphonophores are individuals extending many meters through the surrounding water, their translucent bodies drifting with slow currents that scarcely disturb the silence around them. Seen from a distance, they resemble strands of starlight suspended beneath the sea. The comparison feels especially fitting because both stars and deep-sea organisms produce light in darkness, each according to entirely different laws of nature. Above, nuclear fusion shines across unimaginable distances. Below, carefully controlled chemical reactions create gentle flashes within living cells. Two different stories, one shared language of light. Sometimes the boundary between ocean and sky feels surprisingly thin. Both are vast. Both contain regions few people will ever visit. Both reward patience more than haste. And both remind us that much of existence unfolds quietly beyond ordinary experience. Deep beneath the surface, the soundscape is also different from what we might expect. The deep ocean is not perfectly silent. Water carries sound efficiently, allowing vibrations to travel great distances. The distant rumble of underwater earthquakes, the slow cracking of shifting sea ice far away, the songs of whales moving through upper layers of the ocean, and even the subtle movement of sediments all contribute to a gentle acoustic landscape. Many fish produce quiet sounds of their own. Some create low-frequency vibrations by contracting muscles against specialized structures within their bodies. Others grind small bones together or use their swim bladders as resonating chambers. These sounds are rarely loud. They are conversations suited to an environment where energy is precious and unnecessary effort is avoided. Researchers place sensitive hydrophones deep beneath the ocean to record these underwater soundscapes. Listening to such recordings often reveals long periods of gentle ambient noise, interrupted only occasionally by the distant call of a whale or the subtle crackle produced by countless tiny organisms. The recordings have a peaceful quality, not because nothing is happening, but because everything happens without urgency. Even sound seems to drift more patiently here. The whale songs that sometimes reach the abyss are particularly moving to consider. A whale swimming near the surface may never descend anywhere close to the greatest depths, yet its voice travels through layers of water, touching regions its body will never visit. A message carried farther than the messenger. Perhaps ideas sometimes travel that way as well. A thoughtful observation may continue quietly through generations, long after the person who first spoke it has become part of history. Knowledge itself often resembles an ocean current. It moves gradually. It connects distant places. It carries something valuable without demanding attention. Near the seafloor, a small octopus settles upon a rocky outcrop. Its skin changes texture almost imperceptibly until it resembles the surrounding stone. Many octopus species possess extraordinary control over specialized skin cells that allow them to alter both color and texture. In the deepest regions, where little natural light exists, camouflage may rely as much upon shape and subtle contrast as vivid coloration. The octopus waits, not from laziness, from wisdom shaped by evolution. Waiting consumes almost no energy. Waiting allows opportunities to arrive naturally. When a small crustacean wanders close enough, the octopus moves with smooth precision. The motion is brief. Then stillness returns. Its large eyes continue observing the surrounding darkness. Each arm gently explores nearby surfaces with thousands of sensitive suckers capable of tasting and touching at the same time. For an octopus, the world is understood through many forms of perception working together. Humans often rely most heavily on vision. Other animals distribute their attention differently. Nature has invented countless ways of experiencing the same planet. The deep sea quietly encourages humility in this regard. Our own senses reveal only one version of reality. Other creatures inhabit worlds shaped by chemical signals, electrical fields, pressure changes, magnetic orientation, and vibrations too subtle for us to notice unaided. Science does not diminish wonder by explaining these differences. It expands wonder by showing how many different ways there are to belong to the same earth. Above the waves, dawn will eventually arrive somewhere. Clouds will catch the first light of morning. Birds will begin another day's flight. Leaves will stir in a gentle breeze. Yet thousands of meters below, none of these transitions will be visible. The abyss will remain as it has through countless nights and countless days, cool, dark, and quietly alive. Its creatures will continue their patient routines without needing to know whether the surface is wrapped in sunlight or moonlight. There is something deeply reassuring about that continuity. Not every corner of the world changes with every passing hour. Some places remind us that existence can unfold at a gentler pace, where the measure of time is not the ticking of a clock, but the slow drift of water, the steady pulse of living light, and the quiet persistence of life that has learned, over millions of years, that there is no need to hurry through eternity. There are moments when the boundary between living and non-living matter seems especially gentle. Along the floor of the deep ocean, minerals settle beside shells. Shells slowly become part of the sediment, and that sediment eventually forms rock over spans of time almost too large for the imagination to comfortably hold. The living world and the geological world are not separate stories. They are chapters within the same long narrative, each influencing the other with extraordinary patience. If a single grain of fine sediment could tell its history, it might begin high in a mountain range where wind and rain gradually loosened it from solid stone. A river would have carried it toward the sea, rolling it softly among countless other grains before releasing it into the ocean. There it would drift, settle, perhaps rise again in a current, and eventually come to rest upon the abyssal plain. Its journey might require thousands of years. No destination was hurried. No step was wasted. The grain would simply respond to gravity, flowing water, and time. Many of the creatures living nearby experience the ocean in much the same way. They do not fight the slow movement of their environment. Instead, they belong to it, allowing currents, chemistry, and the quiet rhythm of the earth itself to shape their lives. Among these patient inhabitants are deep-sea sea spiders. Despite their familiar name, they are only distant relatives of the spiders that weave webs among grasses or quietly wait beneath leaves after a summer rain. Sea spiders belong to an ancient lineage of marine arthropods that has explored the oceans for hundreds of millions of years. Some species are no larger than a grain of rice. Others, especially those inhabiting colder deep waters, grow surprisingly large through a phenomenon that scientists continue to investigate. One contributing factor may be the greater availability of dissolved oxygen in colder environments, though several influences are likely involved. Their long, delicate legs seem almost impossibly slender. Their bodies are so compact that portions of their digestive system extend into those legs, quietly distributing nutrients throughout the animal. To human eyes, this arrangement appears unusual. To evolution, it is simply another successful solution. Nature is wonderfully unconcerned with whether an idea appears familiar. It asks only whether it works. Nearby, tiny worms weave through the sediment, creating narrow tunnels invisible from above. These burrows gently stir the upper layers of the seafloor, mixing oxygen into places that would otherwise remain isolated. This quiet process is known as bioturbation. It rarely attracts attention. There are no dramatic movements or sudden transformations. Yet, over centuries and millennia, the collective work of countless small animals profoundly changes the chemistry and structure of the seabed. Sometimes the greatest transformations arise from innumerable gentle actions repeated over immense stretches of time. Forests grow one leaf at a time. Coral reefs expand one tiny skeleton at a time. The ocean floor is reshaped by creatures scarcely noticed individually. There is a peaceful lesson hidden within that observation. Small efforts, patiently continued, often become part of something much larger than themselves. Far above, rain may be falling across distant hills. Each drop lands with a sound too soft to be heard beyond a few meters. Yet together those countless drops fill streams. Streams become rivers. Rivers carry minerals to the sea. Eventually, those minerals drift downward into the deep ocean, where another generation of small animals quietly incorporates them into the endless cycle. The planet is remarkably good at connecting distant events. A storm crossing a mountain range and a worm beneath 4,000 meters of water may seem unrelated. Yet they participate in the same continuous earth. In some regions of the deep sea, the sediment is interrupted by scattered stones carried there through extraordinary journeys. During past ice ages, glaciers slowly advanced across continents, gathering rocks of every size. When portions of those glaciers eventually reached the sea, great blocks of ice broke away to become icebergs. As the icebergs drifted into warmer waters, they gradually melted. Embedded stones, carried perhaps hundreds or even thousands of kilometers from their original homes, quietly sank to the ocean floor. Scientists call these isolated stones drop stones. Imagine a lonely boulder resting upon soft sediment where no nearby mountain exists. Its presence tells a story. Long ago, it belonged to a distant landscape beneath open skies. Then it traveled within moving ice. Now it rests forever beneath perpetual darkness. Every object carries history. Sometimes that history simply requires patience to read. Around such stones, life often gathers. Hard surfaces are valuable in regions where the seafloor is otherwise soft. Sponges attach themselves securely. Corals establish small colonies. Sea anemones extend delicate tentacles into passing currents. Crustaceans shelter in the narrow spaces beneath overhanging edges. One stone becomes a neighborhood. One ancient traveler quietly supports new generations of life. Elsewhere, delicate feather stars cling to rocky ledges. Although related to sea stars, their appearance is altogether different. Graceful arms branch repeatedly into fine feathery structures, creating broad surfaces for collecting microscopic food drifting through the current. When viewed in gentle illumination, they resemble underwater ferns moving in a breeze that never truly stops. Each arm unfolds according to patterns that mathematicians often describe using principles of branching found throughout nature. Similar patterns appear in trees reaching toward sunlight, in rivers spreading across floodplains, and even in the tiny airways inside our own lungs. Nature often returns to familiar geometries, not because it repeats itself carelessly, because certain forms quietly solve similar challenges again and again. Branching increases surface area. Surface area allows greater exchange. Whether gathering sunlight, oxygen, or drifting food, the principle remains beautifully consistent. The language changes. The underlying idea endures. As remotely operated vehicles glide through these landscapes, their lights briefly reveal colors almost never seen under natural conditions. Many deep-sea animals appear pale, white, or transparent. Others display rich reds that seem almost black in the darkness, because red wavelengths do not travel far through seawater. Under artificial light, hidden crimson corals suddenly glow with unexpected warmth. Orange sea stars emerge from shadows. Lavender sponges reveal subtle hues. Then, as the vehicle continues onward and its lights fade into the distance, every color gently returns to darkness. The animals themselves have not changed. Only our ability to perceive them has shifted. This happens often in science. New instruments do not create reality. They simply allow us to notice what was already quietly present. Microscopes revealed unseen cells. Telescopes uncovered distant galaxies. Deep-sea submersibles introduced us to landscapes that had patiently existed all along. Knowledge frequently begins not with changing the world, but with seeing it more clearly. The history of deep ocean exploration is surprisingly recent. For most of human existence, the deepest parts of the sea remained entirely beyond direct observation. Sailors crossed the surface. Fishermen worked coastal waters. Natural philosophers wondered what might exist below. But the crushing pressure and immense darkness made exploration extraordinarily difficult. Only during the last century have technological advances allowed researchers to spend meaningful time observing these hidden environments. Even now, each expedition explores only a tiny fraction of the seafloor. The ocean remains vast beyond comfortable comprehension. More than 70% of Earth's surface is covered by water. Much of that lies at depths where very few human visitors have ever traveled. It is quietly humbling to realize that our own planet still contains regions less familiar than some celestial bodies, whose surfaces have been photographed from space. Distance is not measured only in kilometers. Sometimes it is measured by accessibility. The deep ocean may lie directly beneath ships crossing overhead, yet remains separated by barriers of pressure, darkness, and engineering that require remarkable ingenuity to overcome. Still, year after year, scientists continue their careful work, not to conquer the abyss, not to diminish its mystery, but to listen, to observe, to understand a little more than before. Every sample collected, every photograph recorded, every newly described species becomes another sentence added to humanity's growing conversation with the natural world. The conversation is far from complete. Perhaps it never will be. That incompleteness is not a failure. It is an invitation. It reminds us that curiosity can remain gentle. We do not need every answer immediately. Some questions are companions for generations. Some discoveries require decades of patient observation. Some truths emerge only after thousands of careful measurements quietly agree with one another. The ocean itself seems entirely comfortable with such pacing. Its currents do not rush. Its sediments do not hurry. Its oldest corals have no concern for calendars. Its deepest valleys continue waiting with remarkable serenity. And somewhere, beyond the reach of sunlight, a small sponge is filtering another stream of cold seawater exactly as it did yesterday, exactly as it will tomorrow, participating in a rhythm that has endured through ice ages, shifting continents, and the quiet unfolding of millions upon millions of years. The farther researchers have traveled into the deep ocean, the more they have come to appreciate that even the quietest environments possess their own subtle seasons. These seasons are not marked by blossoms opening in spring or leaves turning gold in autumn. Instead, they are shaped by distant events occurring far above, where sunlight touches the sea and microscopic life quietly flourishes. Near the surface, every ray of sunlight becomes part of a vast conversation between light, water, and living cells. Tiny phytoplankton drift through the upper ocean, capturing energy from the sun through photosynthesis. They are almost unimaginably small, yet together they produce a significant portion of the oxygen in Earth's atmosphere. Each individual life is brief. The collective story has continued for hundreds of millions of years. When conditions are favorable, these microscopic organisms multiply into enormous blooms stretching across hundreds of kilometers. Satellites orbiting far above Earth sometimes observe these blooms as delicate swirls of green or turquoise spreading through the sea like slow brushstrokes upon a blue canvas. Most people watching the ocean from a beach never notice them. Yet the deep ocean quietly depends upon them. Eventually, countless microscopic cells complete their lives. Some are consumed by tiny animals. Others begin the long descent toward the abyss as part of the continual snowfall of organic matter. During these periods, the deep seafloor may receive a little more nourishment than usual. Scientists studying long-term observatories have found that some deep-sea animals respond to these distant seasonal changes, despite living thousands of meters below the waves. A sea cucumber may become slightly more active. Certain worms reproduce. Microbial communities gently shift in response to the increased availability of food. It is remarkable that an event beginning beneath bright summer sunlight can quietly influence life in perpetual darkness months later. The ocean carries news with extraordinary patience. Its messages travel not as words, but as drifting particles, dissolved chemicals, and slow-moving currents. Every layer remains connected to those above and below. The connections simply unfold on timescales that invite careful observation. Imagine standing beside an old forest at dusk. A leaf falls from a towering tree. It lands softly among moss and ferns. Over many months, it becomes part of the soil, nourishing roots that will one day support new growth. Marine snow follows a similar path. It is the forest floor of the sea. Every tiny fragment carries with it the memory of sunlight, transformed into nourishment for places where dawn never arrives. Among the quiet recipients of this slow gift are small deep-sea snails. Their shells vary in shape from graceful spirals to smooth, rounded forms, each reflecting the gradual pressures of evolution. Some graze upon bacterial films growing on rocks. Others feed upon organic particles that settle gently onto the seabed. The shells themselves are remarkable structures. Layer upon layer of calcium carbonate is carefully assembled by the animal over the course of its life. Tiny imperfections become part of the final pattern, recording periods of growth, much like the rings of a tree quietly record passing years. Long after the snail itself has completed its life, the shell may remain upon the seafloor. Gradually, it becomes a shelter for another small creature. Eventually, it may break into smaller fragments. Those fragments settle among the sediment. In time, they become part of future stone. Nothing is truly isolated. Every ending becomes material for another beginning. Nearby, a hermit crab carefully examines an abandoned shell. Unlike true crabs, hermit crabs possess soft, vulnerable abdomens that require protection. Instead of growing a shell themselves, they borrow one that another animal has left behind. As they grow larger, they quietly search for new homes. Scientists observing hermit crabs have noted that some species seem surprisingly deliberate in their choices. A shell that is too small limits future growth. One that is unnecessarily large requires extra energy to carry. Balance, once again, quietly guides survival. The deep sea is filled with examples of measured decisions, not conscious planning in the human sense. Rather, behaviors refined over countless generations until they fit the surrounding world with elegant efficiency. Watching such an animal slowly inspect one shell after another invites a kind of gentle admiration. Even here, beneath kilometers of water, there is careful attention to finding a place that feels just right. Perhaps all living things seek something similar. Not perfection, simply a place where life can continue comfortably. Far above, waves continue their endless conversation with distant shores. Children search for shells washed onto beaches, often unaware that every shell once belonged to a living animal carrying out its quiet existence. Some originated in shallow coastal waters. Others came from remarkable depths before currents gradually lifted them into shallower environments over long periods of time. Holding a shell invites an unusual thought. Its original owner experienced an ocean entirely different from our own. Its world was understood through water pressure, chemical traces, and subtle currents. Yet now, the shell rests comfortably in a human hand beneath open skies. Two lives separated by biology become connected through a single object shaped with extraordinary patience. Elsewhere, on the abyssal plain, long transparent sea cucumbers drift just above the seabed. Unlike their bottom-dwelling relatives, these species spend part of their lives suspended in the water, gently swimming through slow undulations of their flexible bodies. Their movements seem almost weightless, not because gravity has disappeared, but because water patiently supports them from every side. Watching such graceful motion encourages a slower way of seeing. Every curve unfolds naturally. Every change in direction appears almost effortless. Nothing is abrupt. Nature often achieves elegance through simplicity. Many deep-sea animals follow this quiet principle. Instead of resisting the surrounding water, they cooperate with it. Instead of forcing movement, they allow movement to emerge from gentle interactions between body and current. The same lesson appears elsewhere across Earth. A soaring bird works with rising air. A sailing vessel moves with the wind. Seeds drift upon autumn breezes. Clouds reshape themselves around invisible currents. Strength often includes the wisdom of cooperation. In another part of the deep ocean, an ancient volcanic rock supports a colony of soft corals that has likely remained undisturbed for centuries. Each tiny polyp extends delicate tentacles into passing currents. Minute particles drift close. The tentacles withdraw. Another small meal quietly enters the endless cycle of living. Generation succeeds generation. The colony slowly expands. If no major disturbance occurs, it may continue this gentle rhythm for hundreds of years. Imagine returning to the same place every century. 1,000 years pass. The coral is larger. The surrounding community has changed in subtle ways. New sponges have attached nearby. A few species have disappeared. Others have arrived. The current still flows. The darkness remains complete. The patient work continues. Time in the deep ocean rarely announces itself dramatically. It accumulates, layer upon layer, moment upon moment, much like the sediment beneath it. Researchers sometimes recover these corals to study their internal growth patterns. Just as trees preserve rings reflecting changing environmental conditions, some deep-sea corals record variations in ocean chemistry within their skeletons. Careful analysis allows scientists to reconstruct aspects of the ocean's past. Ancient currents, changing temperatures, shifts in dissolved carbon. The coral becomes both organism and historian. Its quiet life leaves behind a record that helps us better understand the changing earth. It is beautiful to consider that knowledge may arrive through such gentle means, not from loud declarations, not from sudden revelation, but from patiently listening to what a slowly growing animal has been quietly recording for centuries. Science often advances in exactly this fashion. A careful observation, another observation, years of comparison. Gradually, a clearer picture emerges. Understanding grows not unlike a coral colony itself. Small additions, consistent effort, remarkable results. Above the sea, evening begins to settle across another coastline somewhere in the world. The sky softens from bright blue toward lavender and gold. Birds return to sheltered branches. first stars quietly appear. Moonlight begins spreading silver pathways across calm water. To anyone standing upon that shore, the ocean seems peaceful. They cannot see the immense landscapes hidden beneath. They cannot hear the slow currents passing through underwater valleys. They cannot watch the transparent jellyfish drifting through darkness, or the patient sea cucumber making its quiet journey across ancient sediment. Yet all of it is there, every moment, every day, every night. The unseen does not become less real simply because it escapes our attention. Perhaps that is one of the most comforting ideas the deep ocean offers. Much of the world continues its gentle work without asking to be noticed. Forests quietly produce oxygen. Fungi patiently return fallen trees to the soil. Tiny plankton support entire oceans. Cold currents circle the globe over centuries. The deepest valleys shelter lives perfectly adapted to darkness. The planet is filled with quiet acts of persistence. And as another delicate flake of marine snow begins its slow descent from the bright waters above, countless unseen creatures wait with the same calm patience they have practiced for millions of years, trusting the steady rhythm of an ocean that has always known how to take its time. In the deepest parts of the Pacific Ocean, there are valleys so profound that even the highest mountains on land would disappear beneath the water if placed within them. These immense depressions are known as ocean trenches, formed where one tectonic plate slowly bends beneath another in a process that has shaped our planet for hundreds of millions of years. The word slowly is especially important here. The plates themselves move only a few centimeters each year. From the perspective of a single human life, they appear perfectly still. Yet, given enough time, they reshape continents. They raise mountain ranges toward the clouds. They open new oceans and gently close old ones. The earth is always changing. It simply prefers to do so with remarkable patience. Among these great trenches, the deepest known is the Mariana Trench, where the seafloor reaches nearly 11 kilometers beneath the ocean's surface. If one were somehow able to stand upon that distant bottom and look upward through perfectly transparent water, the surface would be unimaginably far away. Of course, seawater is never perfectly transparent over such distances. Light disappears long before reaching those depths. The world becomes one of gentle darkness, immense pressure, and quiet persistence. Yet even here, life has found a way. When scientists first began exploring these extraordinary depths, there was understandable curiosity about whether anything could survive under such immense pressure. The answer, revealed through careful exploration, was quietly reassuring. Life had already arrived long before we asked the question. Tiny, single-celled organisms inhabit the sediments. Small crustaceans wander across the seabed. Soft-bodied sea cucumbers continue their patient journeys. Delicate worms weave through fine layers of ancient mud. Some fish have even been observed at astonishing depths, though their distribution appears to have practical limits related to the biology of their cells. Scientists continue investigating exactly where those limits lie. Every expedition refines our understanding just a little further. There is something deeply comforting about the fact that life does not end where conditions become unfamiliar to us. Instead, it changes. It adapts. It discovers new possibilities. Pressure, which seems so intimidating when expressed as numbers, is simply another part of daily existence for these remarkable organisms. A human visitor would require an extraordinary vessel to withstand such conditions. The animals living there require only the bodies that evolution has patiently shaped across millions of years. Within their cells are specialized molecules that help proteins continue functioning under tremendous pressure. Membranes remain flexible despite the surrounding forces. Chemical reactions proceed quietly, neither hurried nor delayed beyond what life requires. Everything is adjusted. Everything belongs. Nature has an extraordinary ability to make the unusual become ordinary. Elsewhere in the trench, the sediment is remarkably soft. Each tiny particle has traveled a long journey before arriving. Some originated as microscopic shells drifting downward from sunlit waters. Others came from distant volcanoes, carried through the atmosphere before settling into the sea. Mineral grains arrived through rivers flowing across continents. Dust crossed entire oceans on high winds before gently sinking through the water column. Each grain carries a different history. Together they form the floor of one of Earth's most remote landscapes. If we could somehow gather a handful of this sediment and examine it beneath a microscope, we would discover a world hidden inside another world. Tiny fossils, minute mineral crystals, single-celled organisms, bacteria quietly processing organic matter. Nothing about the sample would appear dramatic, yet within it would exist countless stories spanning geological ages. Sometimes wonder resides not in what is large, but in what patiently accumulates. Researchers studying these sediments have discovered that even the deepest trenches act as important gathering places for organic material. The shape of the trench gently funnels drifting particles downward. Marine snow, already descending through the immense water column, eventually settles into these quiet valleys where generations of organisms continue the endless work of recycling nutrients. The deepest places are not empty. They are careful collectors. It is an elegant image. The earth itself seems to gather what falls, holding it gently within its deepest folds before slowly returning those materials to larger planetary cycles over immense spans of time. Nothing is truly forgotten, only transformed. Among the most delicate inhabitants of trench environments are tiny amphipods. Though only a few centimeters long, these crustaceans have adapted to conditions that challenge even our most advanced technology. They move patiently across the sediment, searching for fragments of organic material carried downward from worlds they will never see. Scientists have occasionally recovered amphipods from great depths while studying the chemistry of the deep ocean. These investigations help researchers understand not only the biology of the animals themselves, but also how substances move through marine ecosystems. Each small discovery adds another piece to the larger picture. Science often advances quietly, not through sudden leaps alone, but through thousands of careful observations assembled over many years. A single measurement rarely tells the entire story. Many measurements, gathered patiently, begin revealing patterns. The deep sea appreciates this method. Its own history is written through accumulation rather than haste. Far above, clouds drift across another afternoon sky. Rain begins falling over a mountain forest. Streams awaken. Water gathers into rivers before beginning another journey toward the sea. Eventually, perhaps years from now, a tiny mineral particle released by that rain may begin descending toward the abyss. The connection is invisible, yet it exists. A raindrop striking a leaf, and a sea cucumber crossing the deepest plain belong to the same planetary cycle. Earth is wonderfully interconnected. Sometimes, the links simply require longer timescales to become visible. Not all life in the trench remains upon the sediment. Tiny, transparent creatures drift just above the bottom, carried gently by currents too subtle to notice without careful instruments. Some resemble fragile balloons. Others possess long trailing filaments extending gracefully through the surrounding water. Many are nearly invisible except when illuminated by research lights. Transparency itself becomes a useful adaptation. Without sunlight, camouflage takes different forms. Some animals disappear by reflecting almost no light at all. Others become so clear that only faint outlines reveal their presence. There is a quiet beauty in such simplicity. To exist without demanding attention. To become part of the surrounding water rather than standing apart from it. Nearby, bacteria continue their silent work. These microscopic organisms are among the oldest forms of life on Earth. For billions of years, they have transformed chemicals, recycled nutrients, and quietly supported ecosystems far larger than themselves. They ask for no recognition. Yet without them, the living world would be profoundly different. In every forest, every lake, every handful of soil, every ocean, invisible communities of microorganisms sustain the larger tapestry of life. The deep sea is no exception. Indeed, it may be one of their greatest kingdoms. Scientists continue discovering new microbial species in the deepest sediments, expanding our understanding of life's remarkable diversity. Some organisms appear capable of surviving with astonishingly little available energy. They grow slowly. They divide infrequently. Their entire existence unfolds at a pace difficult for us to imagine. Yet, given enough time, even the quietest metabolism becomes part of Earth's enduring story. Perhaps patience itself is one of life's oldest adaptations. The moon continues its steady orbit overhead, unseen from these depths. Its gentle gravitational pull influences tides across the globe, subtly shaping the movement of oceans that extend all the way to the trench floor. The stars continue shining beyond the atmosphere. The planets continue circling the sun. The galaxies continue their slow journeys through the expanding universe. And beneath nearly 11 kilometers of water, a tiny amphipod quietly explores another patch of sediment. Scale is a curious thing. Universe is unimaginably vast, yet significance does not depend upon size. A galaxy follows gravity. An amphipod follows chemical traces through soft mud. Both participate in the same universe. Both obey the same physical laws. Both remind us that nature expresses itself through astonishing variety while remaining quietly unified. As exploration continues, researchers develop ever more capable instruments for reaching these distant places. Stronger materials, more sensitive cameras, gentler robotic arms, improved sensors that can detect tiny differences in chemistry, temperature, and pressure. Each technological advance opens another small window into a world that has waited patiently for millions of years. The trench itself is in no hurry. It has endured ice ages, asteroid impacts, changing coastlines, and the rise of humanity without altering its calm rhythm. It will almost certainly remain long after our own generation has passed into history. There is no sadness in that thought, only perspective. The deep ocean reminds us that permanence belongs not to individuals, but to the ongoing processes that sustain the earth. Currents continue, sediments settle, life adapts. The planet quietly breathes through cycles far older than memory. And somewhere in the immense darkness of the trench, another tiny grain of ancient sediment settles softly onto the seabed, joining countless others in a patient archive that grows, almost imperceptibly, one silent layer at a time. There are times when the deep ocean seems less like a place and more like a state of quiet existence. Distances become difficult to judge when there are no trees, no clouds, and no horizon softened by sunlight. A rocky outcrop may emerge gradually from the darkness, not because it is moving, but because the observer is drifting patiently toward it. Beyond its edges, the black water continues without visible boundary, giving the impression that the sea extends not only outward, but inward as well, inviting a slower way of noticing the world. Human beings have always measured distance with familiar landmarks, across a valley, beyond a river, over a mountain pass, across an open field. The deep ocean offers very few such references. Its scale is expressed through absence. The space between one rocky ridge and the next may stretch for many kilometers. A single sponge may stand alone upon the seafloor for decades, without another large organism growing nearby. To us, this might seem lonely. Nature appears to experience it differently. Solitude and isolation are not always the same thing. A sponge filtering water is connected to every current that passes through it. Those currents have traveled from distant parts of the ocean. They carry dissolved minerals, microscopic organisms, oxygen, and traces of waters that may once have flowed beneath Antarctic sea ice or across warm tropical seas. Even while remaining rooted in one place, the sponge participates in journeys that span the globe. It never leaves home. the ocean comes to visit. Water itself becomes the traveler. This quiet exchange has continued for as long as oceans have existed. Each passing current carries with it a subtle memory of somewhere else. Not memory in the way we remember childhood or familiar voices, but memory preserved through temperature, salinity, dissolved gases, and countless tiny chemical signatures that scientists have learned to read with remarkable care. Oceanographers often describe individual masses of water almost as though they possess identities. A parcel of deep water formed near Antarctica may retain certain characteristics for centuries as it slowly circulates through the world's oceans. Its temperature changes only gradually. Its chemistry evolves little by little. It becomes recognizable through careful measurement. It is extraordinary to think that water itself can carry a history across such immense distances. In a sense, every current tells a story. Some stories begin beneath sea ice. Others begin where warm sunlight touches tropical waters. Eventually, they meet in the quiet darkness below. The deep ocean becomes a library where many distant histories gently converge. Among the quiet inhabitants of these waters are sea lilies. Despite their graceful appearance, they are not plants at all. They belong to the echinoderms, the same broad family that includes sea stars, brittle stars, and sea urchins. Their ancestors flourished in ancient seas so long ago that many of their fossils became part of limestone cliffs that now overlook modern coastlines. Long before people walked beside those cliffs, the living animals themselves waved gently beneath prehistoric oceans. Today's sea lilies preserve something of that ancient design. Some attach themselves permanently to the seafloor using slender stalks. Others are capable of slowly releasing their grip and drifting to a new location before anchoring once again. Their many feather-like arms extend gracefully into passing currents, collecting tiny particles carried toward them. Watching them in the light of a research vehicle, one could almost mistake them for delicate underwater trees moving in an invisible breeze. Nothing about their motion feels hurried. The current arrives. The arms respond. Food is gathered. Life continues. The simplicity is deeply calming, not because it lacks complexity, but because every action seems perfectly suited to its purpose. Evolution often produces beauty through quiet efficiency. Nearby, a small shrimp pauses upon a rock. Its long antennae gently explore the surrounding water. These delicate structures are remarkable sensory instruments. Minute changes in water movement, faint traces of dissolved chemicals, and subtle contact with nearby objects all become information. The shrimp inhabits a world composed of signals that humans cannot perceive directly. Every species experiences its surroundings through a unique combination of senses. A bat navigates with echoes. A shark detects tiny electrical fields. Migratory birds respond to Earth's magnetic field in ways scientists continue to investigate. Deep-sea crustaceans follow delicate chemical pathways invisible to our eyes. Each perspective reveals a different version of the same planet. Science continually reminds us that reality is richer than our own senses alone can describe. There is something wonderfully humbling in that realization. Our experience of the world is genuine. It is simply not complete. The deep ocean invites us to imagine other ways of belonging. Far above, the surface waters continue, reflecting changing skies. Clouds gather, rain falls. The wind strengthens for a while before becoming calm again. None of these events directly interrupt the patient life unfolding several kilometers below. This remarkable stability allows some animals to grow with extraordinary slowness. Certain deep-sea corals, for example, may add only tiny amounts of new skeleton each year. A branch that appears modest in size could represent centuries of steady growth. If we were somehow able to visit such a coral once every 100 years, the changes would be noticeable. If we returned the following morning, nothing would appear different. Growth often hides inside consistency. The same is true in many parts of life. Mountains do not rise in a single afternoon. Forests are not established overnight. Knowledge grows through years of careful learning. Friendships deepen through countless ordinary conversations. Time quietly shapes everything it touches. The deep ocean simply allows us to notice that truth more clearly. Scientists sometimes compare long-lived marine organisms with living archives. Within their tissues or skeletons, they preserve subtle records of changing ocean conditions. Minute variations in chemistry become permanent. Years later, researchers may carefully examine those patterns, discovering clues about temperatures, nutrient availability, or the circulation of ancient waters. The organism itself never intended to keep a record. It simply lived. Its life became a history. Perhaps that is true in quieter ways for all living things. Our actions, habits, and moments of kindness often become part of stories we never realize we are helping to write. Elsewhere on the seafloor, a small octocoral colony provides shelter for tiny brittle stars, whose slender arms curl gently around its branches. The relationship is subtle. The coral gains no obvious benefit. The brittle stars receive a place from which to extend their arms into passing currents. Scientists continue studying many such relationships because ecosystems are often built from countless small interactions rather than a few dramatic ones. Nature prefers networks. Every organism participates in many connections at once. A coral provides shelter. Currents deliver food. Microbes recycle nutrients. Sediment stores carbon. Deep water carries oxygen. No single process stands alone. The strength of the system lies in its quiet cooperation. The same principle appears across the earth. Forests depend upon fungi beneath the soil. Grasslands rely upon insects almost too small to notice from a distance. Rivers support wetlands. Wetlands shelter birds. Clouds form from oceans. Rain returns to rivers. Again and again, the planet reveals itself not as separate pieces, but as an ongoing conversation. The deep sea joins that conversation with remarkable patience. There are also moments of surprising stillness. Researchers sometimes lower cameras onto the seafloor and leave them undisturbed for many hours. When the recordings are later reviewed, long stretches may appear almost motionless. A sponge continues filtering. Fine sediment drifts slowly downward. A distant sea cucumber advances by only a few centimeters. At first glance, almost nothing seems to happen. Yet careful observation reveals continual change. Tiny crustaceans emerge and disappear. A worm briefly extends from its burrow before withdrawing again. A fish passes quietly through the edge of the frame. The water itself carries countless microscopic lives, invisible without magnification. Stillness often contains more activity than we first imagine. Perhaps this is why watching calm water, falling snow, or drifting clouds can feel so peaceful. The movements are gentle enough that the mind begins noticing details it might otherwise overlook. The deep ocean encourages exactly this kind of attention. It rewards patience. It invites observation rather than excitement. It reminds us that understanding often arrives gradually. The first explorers of the abyss could only glimpse small portions of this hidden world. Modern technology has expanded those glimpses into longer conversations. High-definition cameras reveal astonishing textures. Sensitive instruments measure tiny changes in chemistry. Autonomous vehicles quietly map landscapes that remained unseen throughout nearly all of human history. Even so, each expedition returns with a familiar conclusion. There is still more to discover. Far more. The ocean does not become smaller because we learn about it. Our understanding simply grows. The mystery remains generous. It continues offering new questions with gentle consistency. That is one of the comforting qualities of science. Knowledge is not a collection that eventually becomes complete. It is a landscape that gradually widens. Every answer opens another quiet path leading onward. Somewhere beyond the reach of the cameras, another sponge filters another current. Another coral quietly adds an almost invisible layer to its skeleton. Another shrimp patiently explores a rocky ledge with delicate antennae. None of them know they are being studied. None of them need to. They continue their ancient routines with the same calm rhythm that sustained their ancestors through changing climates, drifting continents, and the slow unfolding of geological time. And overhead, though unseen from the depths below, the stars continue crossing the night sky, while beneath them, the great ocean keeps its own patient rhythm, joining sea and stone, darkness and life, in a conversation that has never once required a single spoken word.